Hi, this lesson is on multiplying polynomials, lesson 9.2. You should be on page 562. The diagram at the right shows that a rectangle with a width of x, and you can see that here, and a length of 2x plus 3 has an area of 2x squared plus 3x. So this is just building off what you learned in the algebra tiles. And you can see here I have 2x plus 3 across the top, x down the side. Well, x times x is x squared, x times x is x squared, and then 1 times x is x 3 times. Can you see the 2x squareds and the 3x? There's a picture using algebra tiles of 2x plus 3 times x. Now, obviously, we don't want to use algebra tiles all the time. Those are kind of the training wheels to get us to seeing multiplying polynomials. So, if we read further, you could also get the answer by just using the distributive property. If we use the distributive property, you will see that x times 2x would give me 2x squared, and x times 3 would give me 3x, and you see I'm getting the same thing. In this lesson, you're going to learn several methods for multiplying polynomials. Each method is based on using the distributive property. Let's talk about multiplying a monomial and a polynomial. Now remember, monomial means single or one. Mono is one. So when I see a monomial, I normally think of, and you're not going to see this in the book, I think I'm going to single distribute. I have one thing to distribute through. So let me look at this here. I'm going to take 2x cubed and I'm going to distribute it with x cubed, with 3x squared, with negative 2x, and with 5. Now I'm calling it single distribute because I only have one term, 2x cubed, that I got to distribute through. So when I do that, I'll have 2x cubed times x cubed, which is here, and I'll have 2x cubed times 3x squared, which is here, and 2x cubed times negative 2x, which is here, and 2x cubed times 5, which is here. Now, to get this done right, you got to know the exponent properties from chapter 8. So 2x cubed times x cubed, if I have the same base, I can add those exponents. That's 2x to the 6th. Here, 2 times 3 is 6, and those bases I can multiply, which means add exponents. That's 6x to the 5th. And then negative times positive is negative. 2 times 2 is 4. X to the 3rd and x to the 1st. I can add those exponents. That's x to the 4th. And 2 times 5 is 10, x cubed. Got to know the exponent rules to get each of these individual multiplications done. There, I just got the answer and simplified. I just single distributed. I had a monomial in front. What about multiplying polynomials using a table? Now, the table method, it's okay to use. I wouldn't mark it wrong, but I would say it's kind of the kiddie method. Like if Mr. Keller next year in geometry saw you doing this, he wouldn't mark it wrong, but he would kind of think like that looks like the kiddie method. Okay, so if this is easy for you and you want to do it this way, no problem. It's just as you go up the ladder, it's not wrong. It's just not going to look the same as everybody else's. Okay, we want to find the product of x minus 4 and 3x plus 2. So you notice what they do. It's almost like the lattice method some of you might have learned earlier on as a grade school kid. X minus 4, I'm going to put x and negative 4, and then I have 3x plus 2. Now, first of all, I'm going to multiply x and 3x. Let me highlight these. When I multiply x and 3x, I get 3x squared, which is here. And then I'm going to take, let me get a different highlighter, I'm going to take negative 4 times 3x, and if I multiply those, I get negative 12x, which I'll write in there. Let me highlight that in blue. And then let me take a different color. We'll go with the pink. If I take x and 2 and multiply, I get 2x. Okay, that's what I multiplied when I took the pinks. And let me take orange. If I take negative 4 and 2 and multiply it, I get negative 8, which is down in here. And I'll put that in orange. So now, let's see what I have. I have 3x squared, which you can see here. Negative 12x and 2x I can combine together into negative 10x, which you see there, and then I have negative 8. Well, there's my answer. 3x squared minus 10x minus 8. So we could always use the table method if we wanted to get these solved. Let me use the table method really quick for number 2 here. All right? I'd have a and 3, and I'd have 2a and 1. And if I multiply these out, a times 2a is 2a squared, a times 1 is 1a, 3 times 2a is 6a, and 3 times 1 is 3. Now let me see, I got a 2a squared, these combine together into 7a, and I have a positive 3. That would be the answer using the table method. Again, nothing wrong with it. It looks kind of like the kitty method, but you can use it. Next. Regarding multiplying polynomials vertically, we're going to disregard that. In my 25 years of teaching math, I don't see this often, and I think we have enough to remember, so I don't think it's going to hurt us to not learn how to multiply vertically. We can always change it into the table method, or I would rather have you multiplying them horizontally because 99% of the time, that's how the questions will look in the book or in your problems. So we definitely want to know how to multiply horizontally. Now, first of all, when you multiply polynomials horizontally, let's look at this problem, because this is the first thing to look at. You notice how we have a trinomial here, and we're multiplying it with a binomial. Since I have a trinomial in front, the first thing I think of is I'm going to triple distribute. Now you might be like, what are you talking about? Well, a trinomial has 3 terms. I have to distribute each of those 3 terms through the binomial. So it might be easier to show you with colored pen. Ready? I'm going to do 2x squared times 4x and 2x squared times negative 3, which is going to give me 8x cubed minus 6x squared. Then I have to take 5x times 4x, which is positive 20x squared, and I got to take 5x times negative 3, which is negative 15x. Then I'm going to use a red pen just because it shows up nice. I'm going to do negative 1 times 4x, which is negative 4x, and negative 1 times negative 3, which is positive 3. Can you see how I had 3 different numbers, or 3 different terms? I'll underline them. 1, 2, 3 that I had to distribute. That's why I'm calling this, I got to triple distribute. Now when I do that, let's see what I get. I got to combine my like terms. I have 8x cubed, which is here. These 2 combine together into 14x squared, which is there. These 2, negative 15x and negative 4x, combine to negative 19x, and I have a plus 3, and there I simplified it. When I triple distribute, I get 8x cubed plus 14x squared minus 19x plus 3. FOIL. Now, your parents would have learned how to FOIL, okay? I don't really teach FOILing anymore for the following reason. FOILing only works in one circumstance, and that's if you have a binomial times a binomial. Other than that, it doesn't work. So I've kind of got away from FOIL, and I would just rather tell you this. This way I'm being consistent, and it makes sense no matter what kind of problem we have. Do you notice how I have a binomial times a binomial? Binomial means I have to double distribute. Bi means 2. I got to distribute the 2x with the 4x and the 1. Let me do that. 2x times 4x is 8x squared, and 2x times 1 is 2x. And then I got to take 3 times 4x, which is 12x, and 3 times 1, which is 3. I just double distributed. A binomial has 2 terms. I got to multiply each through. I got to distribute them both. Double distribute. Okay? Let's simplify this. Well, the 8x squared, there's only 1 squared term, so that's alone. 2x plus 12x is 14x, and I have the plus 3. So I don't really even teach FOIL anymore. I wouldn't test you on it. I just call that double distributing. And now it doesn't matter what type of polynomial I have in front. I'm either going to single distribute if it's a monomial, I'll double distribute if it's a binomial, I'll triple distribute if it's trinomial. So when I look at this next example, multiply binomials, the first thing in my mind is I got to double distribute. All right, well, let's look at that. I'm going to take 3a times a, which you see here, and 3a times negative 2, which you see here. And I got to take 4 times a, which you see here, and 4 times negative 2, which you see there. Well, 3a times a is 3a squared, and 3a times negative 2 is negative 6a, and 4 times a is 4a, and 4 times negative 2 is negative 8. And the only like terms I have are right there. Those combined to negative 2a, so I have 3a squared minus 2a minus 8. Why don't you pause the video and try these three real quick. Okay, I'm back. So the first one, you are single distributing. You have a monomial in front, x, so x times 7x squared is 7x cubed, and x times 4 is 4x. The next problem, you have to double distribute. So you can see I'm doing that here. 2x squared plus 7a plus 3, which we've already worked this one out with the table method. And then here, I have to double distribute again. I got a binomial in front, so I'm double distributing. You can see how I color-coded it. And 4n squared minus 21n minus 5. Okay, same thing. Pause the video and try these now. Okay, and I'm back. And the first one, we should be, as you can see, a trinomial in front. We should be triple distributing, which would work out to x cubed plus 4x squared plus 5x plus 2. In the second question, I have a trinomial in front. I ought to be triple distributing. And you can see up here I'll get 6y cubed minus 11y squared plus 13y minus 15. And in the final question, I'm going to double distribute. I have a binomial in front. I should be getting 4b squared minus 13b plus 10. We'll have a few word problems again that go with this, and it's just either single, double, or triple distributing. So here, the dimensions of a rectangle are x plus 3 and x plus 2. Which expression represents the area? Well, area is length times width. So I got to take x plus 3 times x plus 2, and I should double distribute this. I'll let you figure that out for your own and pick the correct answer. And then at the bottom, okay, you're designing a rectangular skateboard park on a lot that is on the corner of a city block, which you can see here. The park will have a walkway along two sides, which you see here. I'm pointing at it. The dimensions of the lot and the walkway are shown in the diagram. Write a polynomial that represents the area of the skateboard park. Let me highlight the skateboard park. It's not the walkway, it's just what's inside the walkway. So I'm trying to highlight that here as you can see it. Okay, so the skateboard park, if from here to here is 33 feet, the skateboard park must be 33 minus x feet wide. And as far as the length, if here to here is 45 feet, if I take away the width of the sidewalk, the length of this park would be 45 minus x. So if I want to find the area, I got to take 45 minus x and multiply it with 33 minus x. That's length and width, which you see here. This would be a double distribute problem. So from here, all you have to do is double distribute, simplify, and that would be the expression for the area of the skateboard park. So this would be it right here. The area would be that expression. So if the walkway is 3 feet wide, I can just plug in 3 for x and then find out the area of the park. I'm going to pause the video here. If you have questions, make sure you ask during class.